Hello. Today I'll explain how spacecraft convert sunlight to electricity. All spacecraft need electrical power for heaters, computers, electronics, mechanical systems, sensors, cameras, and communication equipment. Where does this power come from? There are only two sources that can provide enough energy over long periods of time: solar energy and nuclear energy. In this video, I'll describe solar power for spacecraft in our solar system. The Wikipedia image on my right is that of a solar array on the International Space Station. Power is the rate of energy generation or usage. In other words, it is energy generated or used per time. 1 watt is 1 joule of energy generated or used per second. We can also calculate wattage as voltage multiplied by electrical current. Therefore, if I have an electrical circuit where a 20-volt source is pushing 1/10 amp of current through a circuit, the circuit is using 2 watts of power. In other words, the circuit consumes 2 joules of energy every second. It's commonly known that mechanical and electrical systems can be used to store and transfer energy. But did you know that electromagnetic waves also store energy and can be used to transfer it from one place to another? Light, microwaves, and radio waves are all electromagnetic waves and can be used for this purpose. The power emitted by our sun is 380 trillion watts. A trillion is 24 zeros. This is emitted into space in all directions. It has a power density equal to about 1,400 watts per square meter when it reaches Earth. For planets further away from the Sun, the power density is lower because it drops by the square of the distance from the Sun. Of that 1,400 watts, only an average of about 700 watts per square meter reaches Earth's surface. Losses are due to reflection and absorption in air, caused by clouds, dust, fog, and smoke. In dry areas with high altitudes, the average goes up. You can convert this electromagnetic or solar energy to electrical energy using solar cells or arrays of solar cells. Commercial, space-qualified, triple-junction solar cells are currently about 40% efficient in converting solar power to electrical power. To be conservative, we assume an efficiency equal to 36%. Therefore, the total power density that can be converted to electricity in space near Earth is given by the equation on my right. We find that 504 watts of electrical power per square meter is available if a spacecraft has 20 square meters of solar array area. The total power available is given by the next equation that I now show. That's enough power for a small house, and enough for most satellites. If a spacecraft is traveling to the outer reaches of our solar system, 3 times further from the Sun as Earth, then the solar power density drops by a factor of 1 divided by 9 compared to the solar power near Earth. Now the spacecraft with a 20 square meters solar array produces only 1,120 watts. That may not be enough to power your spacecraft unless you're careful with power usage. When traveling to the outer reaches of the solar system, where solar energy is less dense, nuclear power is required. Here's another example. Assume that you're designing a satellite to orbit Mars and provide continuous communication between Mars and Earth. The satellite will consume an average of 8 kilowatts of power. Batteries will be used to provide power spikes and will charge during periods of low energy usage. The solar array will have 36% efficiency in converting solar energy to electrical energy. How many square meters of solar panels will you need? Earth's solar orbit is about 150 million kilometers, and Mars' solar orbit is about 228 million kilometers. Therefore, the power density of solar radiation at Mars is given by the equation I now show. Since you need 8 kilowatts of power and the solar panel efficiency is 36%, the total area of solar panels required is given by the next equation that I show. You'll need a solar array with 37 square meters of area. If you find this video useful, please give it a like and consider subscribing to the channel. If you want to be notified when new content is added, click on the notification bell. We also need your feedback, so please leave comments. Goodbye.